Hello, everyone. My name is Richard, and I'll be running the CAD workshop for LAFTC Kickoff. So, as you've heard, we have our moderator as well, Raymond Bolanos,
Yep. Hi,
and
everyone.
oh yeah,
Yeah.
we're just gonna be going over CAD, like a brief overview and applications of CAD, and we're gonna also get into CAD, but we're also gonna be just talking about like what it actually is and its fundamentals, basically. So let's begin. Um, Here's an introduction about myself. Raymond and I were both from FTC Team 542 WHS Robotics. So recently, I graduated with a Bachelor of Science degree in Mechanical Engineering at UC Riverside. And now I'm currently pursuing a master's degree in Mechanical Engineering at UCLA. So my main focus or concentration is in design and manufacturing. So I have a lot of experience with CAD. I've done a lot of projects with CAD. And I've actually had some projects as well as an R&D engineer at the Los Alamos National Laboratory in New Mexico as well. So that's about myself. Moving on, let's talk about what is CAD. So CAD stands for Computer Aided Design, and it is essentially the implementation of computers to create, modify, analyze, and optimize a design in a 3D space. So the main software that we'll be using for this workshop is SolidWorks, but you guys aren't limited to using SolidWorks. You guys can use other softwares. So I've listed a few other ones, AutoCAD, Fusion 360, or Blender. So what are some advantages and disadvantages to CAD? So why are we using this? We want to just use CAD to essentially create some virtual model of your robot before you can actually build it in the physical environment. So this helps you kind of build up your list of parts, what you want and what you like need. So once you've actually built your entire robot, it can get a bit complex because there's like hundreds of parts, right? But you can actually create or it automatically generates a list or a bill of materials. So you know what parts you need, the quantity especially, so you know like what you actually can build off of that. So as for disadvantages, SolidWorks or CAD is very time consuming. It's a learning process. So like you won't get stuff right the first time, but you kind of have to figure your self throughout the way. You might encounter some errors or warnings, and that might backtrack you a bit, but it will give you a head start in the end because once you design your robot, it should be pretty quick in terms of building because you know the exact locations and placements of where your parts go together and fit together on the robot itself. So next up, we're going to talk about the applications of CAD. So CAD obviously can be inputted into robotics, biomedical devices, automotive, automotive, and aerospace industry, or basically anything that you can create. So I have some images here, just to show you guys what CAD models look like and how they function. So in the top right, we have the Uber Air, which was created by an alumnus from, or designed by an alumnus from our team, WHS Robotics. And we also have 3D printing as well. So for this one, if you guys aren't familiar with, is the Microsoft HoloLens. It's basically an augmented reality device, so you can just overlay onto, I guess, your eyes, and then you can see like these different images that pop up. So what I did was I created this model of a thermal imager mount. So I basically mounted a thermal imager so you can detect like heat signals and all different traces. And you can see that as an overlay on that augmented reality headset, which is pretty cool. Another thing you can consider is finite element analysis. So this one primarily looks into how like structures or any type of part can have a stress and strain relationship. So how they kind of deform under different types of loads and conditions, such as like pressure as well. So this is just an image of like a belt buckle or like a seat belt type of thing where you can see the stresses are applied towards the center, which is highlighted in red, and that has a greater magnitude in terms of its value. Other types of applications of CAD include modeling and animations. So you can see here in this image on the bottom right, we have a custom ventilator that one of my colleagues had designed for their project. And it includes a complex gear train as well to help it actually function properly. So here is another application of CAD. So kind of going off of that modeling and animation, this is one of my uh, past senior design projects. So for this one, this is a rendered animation from SolidWorks. So the idea of this project is basically my team wanted to build this robot that could autonomously build its own structure from the bottom up, as well as climb that structure once that structure has been built. So you can see here that there's different components to this robot. You have kind of the lifting and climbing mechanism with this dual hook assembly that's being released and that's just traveling downwards. And then there's also the rotating plate mechanism as well, which we'll be talking about in the next animation. But there's also the grabbing mechanism, the cube latch mechanism, which you can see after the structure has been lifted up. So that's the cube latch mechanism. It's basically a four-stage linear slides, and it has a couple servos that have hooks connected to them, and it just latches onto that uh, element. So yeah, so this is just basically building the structure of the structure. All right, so next up is ascending the structure. So once the structure has been built, you use the other set of dual hooks from the linear or from the mechanism, and you have this kind of rotating plate mechanism that basically sets and fixes the position of the robot on the structure so that it can just climb itself up. So for these types of designs that we've generated, it basically uses this kind of intuitive or repetitive motion. So there's nothing really too complex about it. It's just trying to fit everything in the boundaries and such that there's no interference with anything. So yeah, this took a decent amount of work, but it was like worthwhile in the end. All right, so that's the end of applications of CAD. We'll be moving into SolidWorks next. So when it comes to SolidWorks for any other type of CAD software, there are three types of features you want to consider. So the first one is parts, second is assembly, and third is drawing. So part is essentially a feature where you can modify or change some already given commercial off-the-shelf component, or you can create a new component that can be used for 3D printing or anything else. And assembly, on the other hand, basically combines both parts and commercial off-the-shelf components to basically build or connect all the pieces together to build your robot. And finally, your drawing verifies to see whether or not those connections can work properly in terms of their dimensionality and tolerances to see like if there's like no interference or anything. And when it comes to, I guess, FTC robotics, you don't have to like build every part by yourself. There's already step files or other files on the internet that you can find and you can just download. So for like my senior design project, I downloaded most of the parts from Rev Robotics and McMaster-Carr. And you can just kind of see tech resources, FTC CAD. These are kind of like the drop-down menus that you can find on that website. All right, so moving forward, we're gonna move into SolidWorks. So I'm gonna switch over. So when you open up SolidWorks, the first thing you should see is um, the this kind of interface, right? You want to first click on the bottom right and get your dimensions correctly, because you have different units. You have SI, you have American units. So I'm sticking to IPS, so inches, pounds, seconds, which is denoted on the bottom right. So other thing to keep in mind is you have to look at what you have on this side. This side's very important. So it shows you where your point of origin is. So if you just hover over each of these, it'll kind of just display automatically on your screen. So the origin is the orange dot. You have your right plane, top plane, and front plane. So these are all relative to this 3D Cartesian coordinate system, which is just your X, Y, and Z axes. And for this workshop, I'll be creating the game element that was found in the game Skystone. So if you guys are unfamiliar with Skystone, it was a game from a couple years ago, and it's the game element is just kind of like a Lego block. So that's what I'm gonna model today. Something like not too difficult, but not like too simple. So I'm gonna show you like the step by step of how to actually build that element. So first off, I want to click on the top plane. So let's look at the top plane. I click on it and it's selected. So a trick to like moving around your camera angle is clicking Control Spacebar. So if I click Control Spacebar, I have this kind of like box and I can just click on the side, the top face, and it will just kind of adjust the camera view for me. So I want to click sketch and I'm sketching on this 2D plane. If I click the top plane, I'm looking at 2D and click sketch. All right. So once I click sketch, I can draw on this plane. So I have access to all these other features. So I can draw lines, circles, curves, and rectangles and all this. So I'm going to click this rectangle, but I'm going to click the drop down and I'm going to click center rectangle. So this center rectangle basically tells me that I'm starting from the center and I'm dragging out. So if I start from the center or the point of origin, I'm going to drag out and then I just drag it some distance, right? So it's important to note that once you first drag it out, you're going to have all these blue lines. So the color of the lines are really important because they tell you whether or not something is defined or not. When they're blue, it tells you that the sketch is underdefined, which is kind of shown here in the bottom right as well as you're editing your sketch. But now we want to define what the sketch or the dimensions of the sketch. So you can click on Smart Dimension and do so. So you click on Smart Dimension, and then now I can click on, let's say, this line. So if I click on the outside of the line, I can adjust or change the dimension. So in this case, I'm going to change it to 4 inches. All right. So you know now that these are now changed from blue to black lines because now the black lines tell you that they're fully defined from this distance. So now we want to do the same with this one. So you can click the blue line to blue line and you could change this dimension. So this is going to be 8 inches. Okay. So once you see this, now all your lines are black, and that tells you that your sketch is now fully defined, as shown here. So once it's fully defined, that means you can exit out your sketch, and you can go to feature. So feature basically manipulates that sketch either by adding material, so such as like these 5 sections, or removing material, which are these other sections as well. So we're going to add material. So we're going to do an extrude boss. So for this, there's all these other features, but we want to stick to just blind. Blind just tells you you're just going straight up in one direction. And I'm going to adjust the uh, length. So this is going to be your height of your element or your game piece. So it's going to be 4 inches. So once I do that, obviously it change your image, and when it's shaded in yellow, it tells you that it's a preview. So it hasn't been fully converted yet until you click the OK button or the green check, either here or here. So once you do that, now you have your rectangular prism. So we can move on to looking at the smaller extrusions at the top. So I can use my scroll wheel to rotate the object around, and I want to look or do Control Spacebar and look at the top view again. So now I want to put the extrusions, the smaller extrusions at the top. So now we're on the top face. I can click on this face. So now it's highlighted in blue and I can click sketch, which tells me that I'm sketching on this top face. Okay. So once I do that, I typically like to put in some guidelines. So like if you hover over any part of the line, any like side of the object, it can give you like a dot which shows you it's the center line. So I kind of like to drag it out and show where my lines actually are. So I'm using the center line. So if you like hover over the top, you'll see this orange dot that just pops up. Then you can just drag it down and you can see there's like a yellow dotted line that you can hover over and then it'll just click on the line and then that's it. So I just created some guidelines to help me out a bit. And for this horizontal line, I'm specifically using it because I'm using the center rectangle again. As you can see here, center rectangle. So I click on the line, any point on the line, and I just drag it out. Okay. Now I've done that, I can use smart dimension and I'm just making, so these are blue lines, right? So that means they're underdefined. So I can define them by saying it's a 2 by 2 inch square. But keep in mind that even though I defined the square, it's still blue, right? It's still underdefined because that this point here hasn't been specified the distance from anywhere else, right? So if I click on, let's say this point to this line, right? I want it to have a dimension as well. So in this case, I'm going to have it as 2 inches, right? So now, because I set this dimension, now all the lines are black and now it's fully defined. Okay. So now that this is fully defined, we can incorporate a mirror entity. So I can exit out smart dimension and we can incorporate a mirror entity because we want to mirror this square across this line. So entities to mirror, I can just drag it out like this. So now your entities to mirror are all these lines and your point, and you want to mirror about this line. So if I just click on that line, right, yellow always tells you it's a preview, so you can see what's going to happen if you click the check mark. So this is what we want, and we click the check mark, and now we can see the square, or the other square was mirrored about this line. Okay, so this is, or so now your sketch is fully defined. You can exit the sketch, and you could use extrude boss base again. So the good idea about this is that because you created two squares, it gives you two separate extrusions for one single boss extrude. So if I change this, I believe the dimension is 1 inch. So you can now see that once you change that, it shortens in length. And this is what we want. So I'm going to click the check mark. Okay. Uh, so next up is the bottom face, right? So because these are like Lego pieces, they need to fit into one another. We also need to cut the holes on the bottom. So how I'm going to do this is I'm going to go back to looking at the top sketch. So I can always look at my previous extrusions. So like the first one was the base, and the top one are the smaller extrusions. So I can right click on the sketch and just edit that sketch. So I want to just drag the entire sketch and do a Control C. All right. So I'm just copying that sketch, but that's the only thing I'm doing. So if I want to go to the bottom, right? Now I'm looking at the bottom face. You don't see the two squares. I am clicking sketch again. And it tells me if you don't click a plane or any face, it asks you automatically which plane or face you want to sketch on. So I want to sketch on this face, the bottom face. Okay, once I do that, I can do, oh shoot, I guess it doesn't work out. Okay, I kind of encountered this problem earlier. So the copy and paste doesn't work that well because it kind of shifts your sketch a bit. So I'm just gonna do redo the sketch really quickly. So does anyone have any questions so far about what I've done or anything about the software? Okay.
Yeah, they're just all chilling. But yeah, feel free for everyone to ask questions still, because we're just going to go through how to make this part. And if you guys get stuck or if you guys have a question about a certain step, feel free to ask.
Okay, so we're finishing up the sketch. It's fully defined. We can exit the sketch. So now we can click on the sketch and we said earlier we can go to feature and we can extrude cut. So we're going to make a cut in this part. So if I just hover or if I just rotate my component, I can see the lines or the highlighted yellow to see the preview. And this is what we want. We want the 1 inch, right? And it just goes in 1 inch deep. We click OK, and then we can now see the cuts have been made. All right. So your general idea of this Skystone game element is here. But if you want to add more detail and make it look like near exact, you can add other features called fillets or chamfers. So fillets, we're going to use fillets right now. Fillets are basically rounded off edges, right? So there's different types of fillets that you can consider, but we're just going to stick to the constant size fillet. So right now it's highlighted in blue, items to fillet. I want to fillet the sides. So if I click on just these two sides, you can't really see anything yet until you click the full preview. So you need to click full preview to see what you're getting out. So right now, you can change the parameters of the fillet. You can see that this is what it would look like. But because this is a parameter you can always adjust, you can change it to, let's say, 0.5 inches to make it bigger. So this basically shows you the radius of what the fillet would look like. So I can do the same on this side, or these two edges. And then I'll just go back. Oh, whoops. I'll click OK. And then that's it. So now your fillets are inputted. And you can click on the isometric view. Oh, wait, I forgot. Yeah, okay, cool. Yeah, you can just make sure to see that all your fillets are there. If you look at our top view, you can see like your edges are now curved. And then next up, we want to input a chamfer. So a chamfer is basically a diagonal cut instead of a rounded edge. So there's different types of chamfers, just like there are fillets, but we're going to use the angle and distance chamfer type. So right now it's highlighted in blue again, so we want to click on some edges to chamfer. So I'm going to chamfer this side, or the top side. So once you click on like any edge, it's going to show that edge on your interface right there. So if I just click on all of them, it's also going to show you the preview as well. We're going to obviously adjust the parameters of the chamfer, but it's basically like a diagonal cut. Yeah, you could also click the top face as well. So these are two ways of doing it. You can either do the face or the edge. So I've already done this in the previous workshop, but you can always mess with the numbers to get it exactly correct. I believe the dimension or for the distance is 1 inch, and for the angle, it's 10 degrees. So if I do that, then you kind of get a new preview with your adjusted parameters. So if this is what you like, or if it's not what you like, you can always adjust it. But if it is, you can click the check mark and it's chamfered. So now you can see that's done. And for the most part, this part is complete. You could always obviously change the material. You can right click and edit the material. So editing material is good if you want to conduct an analysis, such as how this part would deform or act under like some sort of stress. Or you could just simply change the color. So if I right click on part and I go to appearance, I can click the drop down menu and click on that part. And now I have options to change the color. So I'm going to change it to yellow. And I click OK. And now you have your completed Skystone game element. So now I can go to the file, save as, and I'm going to type in game element. So this, remember, this is the file that we use. It's called a SolidWorks part. Okay, so now we've dealt with parts. Now I'm going to show you guys uh, the assembly. So we're going to go to File, click New, and we're going to go to Assembly. So if I look at this section to my left, I can see what documents have been opened. You can see that we had our game element that was open, but you can also have other assemblies as well. So you can create sub-assemblies and create bigger assemblies off of that. So if I click on game element, I can drag it out to the big screen and I just click it in place. So it's fixed. So if you look at this piece is game element 1 and there's an F which stands for fixed. That means you cannot move it. If I try to drag it, I cannot. But any other component you add after your first element, it can be moved around. So if I just zoom out, I can click on game element and then I can just click here in a random direction. And then, right, the first one was fixed, but now this one can be moved around. Another way you can always adjust this is if I like do it again, like game element, I can always rotate it in any direction I want around an axis. So let's say I want to rotate around the y axis by 90 degrees, I can do that. And I just click rotate y component and I can use that and I can just click anywhere and that's it. So I'll be using these three parts for my assembly. So when it comes to these three parts, right, these two are moving, but I want to make them constrained to this one game element. So I'm going to use what we call a mate. So there's different types of mates. Some are more advanced than others, but mating basically connects two faces or any types of part or section on the part can be connected to another part. So let's say I want to connect this face to this face. I do that and it automatically connects, right? So now I'm limited to 2 degrees of freedom. So I can move around, but I won't be able to rotate it. So if you have two parts like this, you always need 3 mates to connect it and fix this part to this part. So I'm not going to mate these faces, but I'll be mating the side faces. So these sides are going to be next to each other. I'm going to click coincident, and that's it. And then one more coincident is the bottom, so they basically touch. And now you can see that this is now fully defined and cannot be moved, right? I can always go back to look at my mates and see what I have. I have I can always hover over the coincident or the mates and see where they're connected to. So it just basically shows you if you like make a mistake, you can always backtrack by looking at your mates. Next up, I want to do the same with this. So I can do mate and mating to either one of these sides. And then I can do it again with the sides. And then if I want to stack this top game element to this bottom game element, I want to click the bottom face, but click the top face here. So now this is fully constrained and cannot be moved. So this is basically the general idea of how to use uh, mates in the assembly. You could, there's more complex things to do. You can do more sketches. I wouldn't recommend doing sketches just because sometimes it gets a bit too complicated. You can always like measure or look at other properties of your components, and then you can also get rendered images. So I would recommend using Photo View 360 if you want a high quality image based off of. So like, right now it doesn't look like it's like really clean, but you can get like more of a metallic type of exterior. And like if you want to get into a bit more complicated stuff, you can also go to the motion study.
Um,
So
Richard,
if you remember, like,
quick question. Just
yeah,
how do you differentiate between which types of mates to use?
um, it kind of depends. So the most common one is coincident. It's basically two mates that are like touching one another. You can use parallel or perpendicular. So parallel would just make them obviously parallel, but they wouldn't be like fixed. So when it comes to when you have objects that are circular, let's say a pipe or something, you want to attach like a pipe on top of this extrusion. You can do like tangent or something. And yeah, it kind of depends. You could also do a distance mate. So if I have two parts and I want to have a set distance between them, I can just click distance mate and do that. And it'll always obviously change the distance. Yeah, but like sometimes you might need to get into like more complicated mates, and we won't go through that, but if you guys are like new to CAD, I would highly recommend just watching YouTube videos. There's a lot of YouTube videos that goes through like each type of advanced mates. Like I didn't learn this by myself because like you would always like get like warnings or it wouldn't work out in the end. So there's like good videos on YouTube that would help you out and explain it a lot better. So yeah, I would look at that first. Yeah, so yeah, so the last thing I was gonna mention was if you want to go into more advanced things, you could always go into the animation section, which is your motion study. So this is how I was able to do the animation from my senior design project. We're not gonna go through that, but just it gives you another idea of what you can do with SolidWorks. All right, so that wraps up my presentation. Thank you guys for listening. If you have any more questions, feel free to just shoot them in the Discord or contact me at my email, therichardyoung@gmail.com, as shown on the screen. And yeah,
Yeah, feel free
that's
to
it.
stay. We are both pretty much college students. Richard's in graduate school. I'm in my fourth year. So if you guys have any questions regarding that as well, feel free to ask. But yeah, in terms of like team stuff, me and Richard both worked on robot things. Richard was scouting. I was engineering notebook as well. So if you have questions regarding that as well, if you want to chill. But yeah, yeah, pretty relaxed presentation.
I think that went pretty well.
Yeah. Wow, you guys have a good handle on it. No one's really asking questions about how to make the part.
Was that pretty clear
I
on
think you. I mean,
everything?
I guess you're clear, but I mean, I already know everything, so I can't really.
Yeah.
Yeah.